Hi, this tutorial is about polymers, and in this one we're going to look at disposal of polymers, including hydrolysis of condensation polymers. So polymers are obviously really useful because that is what plastic's made out of. So most of the plastics that we use, we need to consider ways of disposing of them, and there's lots of different ways that we can do that. One of the most important factors to consider when you're looking at disposing of polymers is their biodegradability. So we are considering whether these polymers are going to break down naturally or not. And obviously we've got our two different types of polymers, and the two different types have different biodegradabilities. So here we've got your addition polymers. These have come from the reaction of alkene monomers. And we've got your two different types of condensation polymers. So this one is a polyester made from a carboxylic acid and an alcohol, or a dicarboxylic acid and a diol. And this one is a polyamide, which could be made from an amino acid, or it could be from a dicarboxylic acid and a diamine. So these are your two different types, and they have different biodegradability. So addition polymers are non-biodegradable, and this is largely down to the fact that the bonds between the carbons are non-polar. So you're not likely to get an attack in there for hydrolysis to take place. So the bonds between the repeating units are non-polar, so these are unreactive, so they are non-biodegradable. Condensation polymers, on the other hand, they do have polar bonds in between the repeating units, so they are susceptible to attack. So here we will get hydrolysis of an ester group, or if this is the case, we will get hydrolysis of an amide group. So you should be familiar with hydrolysis of esters from previous topics. You should know that you can get acid catalysed hydrolysis and base catalysed hydrolysis. So if we ignore the addition polymers for now, because we know that they are inert, they are non-biodegradable because they have non-polar bonds between repeating units, just look at the condensation polymers. We'll have a little look at hydrolysis of condensation polymers. So looking at the polyester first, that's this one in the blue box. This is obviously formed from a dicarboxylic acid and a diol, or it could be a compound with a carboxylic acid on one end and an alcohol on the other end, but for simplicity's sake we'll say that it's this. And if you cause these compounds to undergo condensation, polymerisation, they will become the polyester, which is here. It's not quite a repeating unit, but that sort of thing, plus water, which will be released as a byproduct. But it is reversible. You can get it to go the other way, where you can take the polyester and you can put the water back into it, and it will split into a dicarboxylic acid and a diol. So this is called hydrolysis. So lysis is breaking apart, hydro meaning using water to break something apart. So you can use water to break polyester down, but as you probably know, if you go out in the rain wearing a polyester jacket, it's not going to biodegrade, it's not going to break down while you're out in the rain. So it's not very fast with just water. So for polyesters, you're better using a base. So they are hydrolyzed by bases. And really all you need to be able to do is write an equation for a given polymer breaking down into its monomers. So you would have your polymer plus water makes whatever your monomers are. And that should be easy enough looking at the structure that you've got. So the other one is the polyamide. So you can break down a polyamide just in the same way. So we've got a dicarboxylic acid and a diamine would react, undergo condensation polymerisation to form a polyamide, looks something like this, plus water. But you can get it to go the other way. So polyamide plus water, you can carry out hydrolysis on it, and it will break down into your dicarboxylic acid and your diamine again. And this time, this one occurs more readily under acidic conditions. So neither of them are particularly good with just water on its own. Far too slow. So we use a base if we're breaking down a polyester, and an acid if we're breaking down a polyamide. Now, acid catalysed hydrolysis, like you would do with polyamides, is absolutely fine because you take your polyamide, you add your water, react it with an acid, and it would break down into its original monomers. But if you remember from looking at hydrolysis of esters, when you hydrolyse something under basic conditions, you don't quite get the same product as you would have had before. So you don't quite get your dicarboxylic acid and your diol as they were when they were monomers. So I'll show you an example of that. So if we start with a generic polyester here, if you were to hydrolyse this, you would expect to get a dicarboxylic acid and a diol. But what actually happens, because you're using a base, if you react it with, for example, sodium hydroxide, instead of getting the dicarboxylic acid, you're going to actually get the carboxylate salt. So just move that up a little bit. So there's your polymer, your polyester, react it with a base to hydrolyse it, which is sodium hydroxide, and instead of getting your dicarboxylic acid, you get a carboxylate salt, in this case sodium salt because of the sodium hydroxide, and that's where your sodium hydroxide appears in your products. That's just something to be mindful of when you're doing hydrolysis with a base rather than an acid. Okay, so disposal of polymers. Now that we know which ones are biodegradable, which ones aren't, we know how they biodegrade by hydrolysis, we can now look at the different ways of disposing of polymers. So there are three main ways that we can dispose of polymers. One of them is incineration, it's burning them. One is burying them in landfill, and the other is recycling them. And each of these three different methods have their advantages and their disadvantages, and that's what you're likely to be asked in an exam, is to give advantages or disadvantages, or both, of one or more methods of disposing of polymers. So we go through some advantages and disadvantages now. Okay, so first of all, we look at incineration, and we'll look at the advantages of incineration. Not many, admittedly, but an advantage of incineration is if you burn the plastics, the heat that is released from the burning plastics, the burning polymers, can be used to generate electricity. So heat can be used to generate electricity. So that's the main positive of incineration of plastics. Along with, if you're incinerating them, at least you're not adding them to landfill, that sort of thing as well. That can be considered to be an advantage. But mainly, the heat from incineration can be used to generate electricity. As for the downsides of incineration, one of them that most people know about is the release of toxic gases. So if you've got a polymer that's got chlorine in it, when you burn it, you're likely to make hydrogen chloride gas. So release of toxic gases is a major disadvantage of incinerating plastics. The other main one is when they are burnt, they tend to make carbon dioxide, which is a greenhouse gas. And I'm sure you can fill in the rest. Greenhouse gas, increased greenhouse effect, global warming, all of that kind of stuff. So that's incineration. Has an advantage, has a couple of disadvantages. Okay, next we look at landfill. So disposing of polymers by burying them in landfill sites also has its advantages in that it is cheap to do and it is easy. Very cheap, very easy. So that's simple enough. The disadvantages, however, there's quite a few for landfill. So disadvantages of landfill, it's mainly the space. So you need a lot of land, free land, that you're not going to use for anything else that you can use for a landfill site. So mainly space, land that is needed. There's also toxins and methane that can be released by bacteria that live in a landfill and that feed off the waste. So released into the atmosphere by bacteria as they slowly biodegrade. And any toxins that remain in the landfill with rain and things like that could be washed into water supplies and cause contamination in the water supply. So landfill also has its advantages and its disadvantages. And finally, the last way of disposing of polymers is to recycle them, and there's a couple of different ways that this can be done. So you could crack the polymers into shorter chains, and you could use that to make new plastics or to make completely different chemicals. Or you could just melt them down and remold them to make new things made out of the same plastic. So before you can do any recycling, the plastics need to be sorted into ones that can be recycled in different ways and some that can't be recycled at all. So that's why you have those little symbols with, you've probably seen them, triangle recycle symbols. They usually have a number inside that will refer to a different type of plastic so that they can be easily sorted. Once they're sorted, you can decide whether they're going to be cracked and processed and turned into new things, turned into different chemicals, or whether they're just going to be melted and remoulded into a new product. So that's recycling. Also has its positives and its negatives. So first of all, it is cheaper to recycle plastic than it is to make new products from scratch. So that's a clear advantage. It also saves on crude oil, so raw materials, saves on raw materials such as crude oil, because you're not having to get more crude oil out to make more plastic products. And the other advantages relate to the other methods of disposing of polymers. So one advantage of recycling is that you're not sending stuff to landfill. So there's less stuff going into landfill, and we do need to reduce our amount of waste that's going into landfill because that's causing a lot of problems. And also, it's better than incineration in that it doesn't release the CO2 into the atmosphere. So we've got less CO2 emissions if you recycle. So cheaper, saves on raw materials, stops stuff going into landfill, and prevents as much CO2 being released from incineration. They are the main advantages of recycling. Okay, and in terms of disadvantages, recycling is very expensive in terms of the processing and the sorting and the making sure that every bit of plastic's gone to the right place to be processed in the right way. So it's very expensive compared with just sending stuff to landfill or incinerating it. Another disadvantage is simply that the processes involved are quite difficult and require many steps. So the cracking, the processing, the remoulding are all kind of technically difficult to achieve. And finally, the plastic that you're recycling is easily contaminated because the process is so long-winded, so many places where you could get contamination. It's quite easy to end up with plastic contaminated, which means it doesn't quite have the same properties that you would have wanted it to have if it was the pure material. So they're the main advantages and disadvantages of recycling. Now, one thing to be aware of is that an advantage of recycling would be that it's cheaper, and a disadvantage of recycling would be that it's more expensive, which makes absolutely no sense. So if you're asked in your exam for advantages and disadvantages of recycling, you have to be really specific about in what way is it cheaper, which makes it a good thing, and in what way is it more expensive, which makes it a bad thing. So it is cheaper compared with making materials from scratch, but it is more expensive compared with incinerating and landfill. So it's cheaper in terms of making new plastics, but it's expensive in terms of disposing of old plastics. So be really careful, make sure that you're dead clear on what you mean by cheaper, what you mean by more expensive. And they are the ways of disposing of polymers. Okay, so that covers pretty much everything you need to know about the disposal of polymers and the hydrolysis of polyamides and polyesters. So make sure that you understand that you cannot hydrolyse addition polymers, but you can hydrolyse condensation polymers. You need to know that polyesters are easily hydrolysed by bases, whereas polyamides are easily hydrolysed by acids. You need to be able to write equations for those, and you need to be able to talk about the advantages and the disadvantages of the 3 different methods of disposing of polymers. And that's all, so thank you for watching.